Preparing for a backend development interview. You've reached Interview Guide, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question, you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What makes an API RESTful, and what practices do you follow when designing REST APIs? A RESTful API exposes resources through predictable URLs and uses HTTP methods correctly. For example, get-users/10 reads, post-users/creates, and put-patch-updates. I also care about status codes, validation errors, pagination, filtering, and versioning. The key is consistency. Clients should understand behavior without reading implementation details. REST is simple and cache-friendly, but complex workflows may need RPC-style endpoints. While answering, focus on resource-based design, HTTP methods, status codes, statelessness, pagination, validation, versioning, and how API consistency improves client integration and maintainability over time. Question 2. What is the difference between authentication and authorization? Authentication proves who the user is. Authorization decides what they can do. In a backend, I usually authenticate with sessions or JWTs, then authorize per route, resource, or action. For example, a user may be logged in but still unable to delete another user's invoice. Good systems centralize policy checks, avoid trusting client roles, log sensitive decisions, and fail closed when permissions are unclear. Make sure to cover identity verification versus permission checks, common mechanisms like JWTs and sessions, role or attribute-based access control, server-side enforcement, and secure failure behavior. Question 3. How do database indexes work, and when can they hurt performance? An index is a data structure that helps the database find rows without scanning the whole table. If queries frequently filter by email, an index on email can turn a slow table scan into a fast lookup. I choose indexes from real query patterns, not guesses, and verify with explain plans. The trade-off is write overhead and storage, so too many indexes can hurt inserts and updates. In your answer, talk about why indexes speed reads, common structures like B-trees, choosing indexes from query patterns, explain plans, and trade-offs in writes and storage. Question 4. What are transaction isolation levels and why do they matter in backend systems? Transaction isolation controls what concurrent transactions are allowed to see. Without it, two requests can overwrite balances, read uncommitted changes, or produce inconsistent reports. I think in anomalies, dirty reads, non-repeatable reads, phantom reads, and lost updates. For money movement, I prefer stronger isolation or explicit row locks. For analytics, weaker isolation may be fine. The right choice balances correctness, throughput, latency, and deadlock risk. Be sure to mention ACID, isolation levels, dirty reads, non-repeatable reads, phantom reads, lost updates, row locking, and why correctness requirements should drive isolation choices. Question 5. How do you decide between SQL and NoSQL databases for a backend application? I choose SQL when relationships, transactions, and ad hoc querying matter. Relational databases are strong for orders, payments, inventory, and reporting because schemas and joins enforce consistency. I choose NoSQL when access patterns are simple, scale is huge, or flexible documents fit the domain, like event logs or user preferences. The mistake is choosing by hype. I start from consistency requirements, query patterns, data growth, and operational maturity. While answering, compare consistency, relationships, schema flexibility, query patterns, scaling requirements, transactions, operational complexity, and examples where relational or document-oriented databases are a better fit. Question 6. How would you implement rate limiting for a public API? A rate limiter protects shared backend resources from abuse, bugs, and traffic spikes. For a simple API, I would use a token bucket per user or IP stored in Redis, with atomic increments and expirations. The response should include 429 status and retry metadata. In distributed systems, I watch for clock skew, hotkeys, and whether limits apply globally, per route, or per tenant. Graceful degradation matters too. Make sure to cover token bucket or sliding window approaches, Redis atomicity, per user versus per IP limits, 429 responses, distributed consistency, hotkeys, and graceful degradation. Question 7. How do you approach caching in backend applications, and what can go wrong? Cache invalidation is hard because stale data can be worse than slow data. I first decide what can tolerate staleness. Product catalogs usually can. Account balances usually cannot. Common patterns are TTL-based expiration, write-through caching, cache-aside loading, and event-driven invalidation after updates. I also protect the database from cache stampedes using locks, jittered TTLs, or request coalescing. The goal is faster reads without correctness surprises. In your answer, talk about cache-aside, TTLs, write-through, invalidation events, stale data tolerance, cache stampedes, hotkeys, and how caching affects correctness as well as latency. Question 8. When would you use a message queue in a backend system? A message queue decouples request handling from background work. If a user uploads a video, the API can store metadata and in-queue transcoding instead of making the user wait. Queues improve resilience with retries, backpressure, and dead letter queues, but handlers must be idempotent because messages can be delivered more than once. I monitor lag, failure rates, and processing time because queue health directly affects user experience. Be sure to mention decoupling, background jobs, retries, dead letter queues, at least once delivery, idempotent consumers, queue lag metrics, and when synchronous APIs are still preferable for user feedback. Question 9. What is idempotency, and why is it important for backend APIs? Idempotency means the same operation can be safely repeated without changing the final result beyond the first successful execution. It is critical for payments, order creation, and retries after timeouts. I usually implement it with an idempotency key stored alongside the request outcome. If the client retries, the server returns the previous result instead of creating duplicates. This makes unreliable networks safer and pairs well with queues. While answering, focus on safe retries, duplicate prevention, idempotency keys, storing request outcomes, payment or order examples, race conditions, expiration policies, and how clients should reuse keys. Question 10. What are the main trade-offs of using microservices instead of a monolith? Microservices are useful when teams and domains need independent ownership, deployment, and scaling. They are not automatically better than a monolith. I split services around business capabilities, such as billing or identity, and keep data ownership clear. The cost is distributed complexity, network failures, observability, versioning, data consistency, and deployment coordination. For many products, I would start with a modular monolith and extract services only when boundaries and scaling pressure are real. Make sure to cover service boundaries, independent deployment, team ownership, data ownership, network failures, observability, consistency challenges, and when a modular monolith is the simpler choice. Question 11. How do you handle API versioning without breaking existing clients? API versioning is about changing contracts without breaking existing clients. I prefer backward-compatible changes first. Add optional fields, avoid renaming meanings, and keep defaults stable. When breaking changes are unavoidable, I use URL or header versions, publish migration timelines, and monitor old version traffic. Internally, contract tests help catch accidental breaks. Good versioning is less about labels and more about respecting client trust. Documentation must match behavior. In your answer, talk about backward compatibility, optional fields, breaking changes, URL versus header versions, deprecation timelines, contract tests, client communication, and monitoring old version usage. Question 12. What is the N+1 query problem, and how would you fix it? The N+1 query problem happens when code fetches one parent list, then runs one extra query per item. It often appears in ORMs when loading related data lazily. For 100 orders, you might accidentally execute 101 queries. I fix it with eager loading, joins, batching, or data loader patterns, then verify with query logs and latency metrics. The best fix depends on cardinality and response shape. Be sure to mention lazy loading, ORMs, query explosion, eager loading, joins, batching, data loader style patterns, query logs, and why cardinality affects the best solution for performance tuning. Question 13. How do you prevent race conditions in backend code? A race condition occurs when correctness depends on timing between concurrent operations. A classic backend example is two requests buying the last inventory item at the same time. I prevent it with database constraints, transactions, optimistic locking using version columns, or pessimistic locks like select for update. I also write tests that simulate parallel requests. Application-level checks alone are risky because multiple servers can execute them simultaneously. While answering, cover timing-dependent bugs, lost updates, concurrent requests, database constraints, optimistic and pessimistic locking, transaction boundaries, testing with parallelism, and avoiding application-only checks across multiple server instances. Question 14. What is the difference between offset pagination and cursor pagination? Offset pagination is simple. Page 5 with limit 20 skips 80 rows. It works for small, stable datasets, but gets slower at high offsets and can miss or duplicate records when data changes. Cursor pagination uses a stable sort key, like created at plus ID, and asks for records after that cursor. It is better for feeds, logs, and large APIs, but less convenient for jumping to arbitrary pages. Make sure to compare offset and cursor pagination, performance at large offsets, stable sorting, duplicate or missing records, API usability, and use cases like feeds or admin tables. Question 15. What are the key security practices you follow when building backend APIs? Securing an API starts with not trusting input or clients. I validate schemas, enforce authentication and authorization server-side, use TLS, hash passwords with strong algorithms, and protect against injection using parameterized queries. I also add rate limits, audit logs, safe error messages, and secret management. For sensitive operations, I consider MFA, replay protection, and least privilege access. Security is layered. One control should not be the only defense. In your answer, talk about input validation, server-side authorization, TLS, password hashing, parameterized queries, rate limiting, safe errors, secret management, audit logs, and least privilege. Question 16. How do logs, metrics, and traces help you operate backend services? Logs explain what happened, metrics show how often or how badly, and traces connect a request across services. For a backend API, I track latency percentiles, error rates, throughput, saturation, and dependency health. Structured logs with request IDs make debugging realistic in production. Tracing helps find whether slowness is in the database, cache, or downstream service. Good observability turns incidents from guessing into investigation much faster. Be sure to mention logs, metrics, traces, request IDs, latency percentiles, error rates, throughput, saturation, dependency health, dashboards, alerting, and incident debugging in distributed systems. Question 17. How would you deploy backend changes with zero downtime? Zero downtime deployment means users keep receiving successful responses while new code rolls out. I achieve it with rolling or blue-green deployments, health checks, load balancer draining, and backward-compatible database migrations. The tricky part is running old and new application versions together. For schema changes, I use expand and contract, add nullable columns, deploy code, backfill, then remove old fields later. Feature flags reduce blast radius during releases. While answering, focus on rolling deployments, blue-green releases, health checks, connection draining, backward-compatible migrations, expand and contract schema changes, feature flags, and rollback strategy during production incidents. Question 18. An API endpoint is slow in production. How would you investigate and improve it? When an endpoint is slow, I start by measuring instead of guessing. I check P95 and P99 latency, traces, database query plans, cache hit rates, payload size, and downstream calls. Common fixes include indexing, removing N+1 queries, caching safe data, batching network calls, and moving non-critical work to queues. I also set timeouts and budgets, so one dependency cannot make the whole request hang forever. Make sure to cover measurement first. P95 or P99 latency, tracing, query plans, cache hit rates, payload size, downstream calls, timeouts, batching, indexing, and queues. Question 19. How do you structure backend code so it remains maintainable as the product grows? A maintainable backend has clear boundaries even if it is deployed as one application. I separate controllers, domain logic, data access, and infrastructure concerns. Business rules should not be buried inside HTTP handlers or ORM callbacks. I keep modules cohesive, define interfaces for external dependencies, write tests around critical flows, and avoid circular dependencies. This makes refactoring easier and creates a path towards services later if needed. In your answer, talk about separation of concerns, controllers, domain logic, repositories, interfaces, cohesive modules, testability, avoiding circular dependencies, and preparing for future service extraction. Question 20. How would you design a simple URL shortener backend? For a URL shortener, I would expose create and redirect APIs. Creation validates the long URL, generates a unique shortcode, stores the mapping, and returns the short link. Redirect reads the code and returns 301 or 302, depending on caching needs. At scale, I add database indexes, cache hot codes, rate limit creation, track analytics asynchronously, and handle collisions with retries. The key trade-off is readability versus code space efficiency. Be sure to mention create and redirect APIs, unique code generation, collision handling, database indexing, caching hot links, redirect status codes, rate limiting, analytics, and abuse prevention. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.